screen in front of you, and you can also find it on the SAM website. The SAM website's learning page, which has a link of the upcoming to the schedule for upcoming webinars, and is also where you can find the recordings of past webinars. So when we're finished with this recording, with this webinar, we'll post it here on the SAM learning page. The SAM website, of course, is where you can find information about SAM and the download links. The home page has a good overview of the model. If you want a general description. And the support page has a user forum where you can post your questions about SAM. That's monitored several times a day. So you'll get immediate response to your questions about SAM here. And you can also search the forum for questions about the model. Whoops. And of course, the SAM website is where you download copies of the software. So there's the search results with topics about weather files. And then the download page. Sorry, the website's a little slow this afternoon. Is where you download the current version of SAM, and then we also post legacy versions for those for various reasons who need to use older versions. There are installation instructions here, a list of features in each version, and other information about versions of SAM. So I'm going to briefly talk about the SAM software release schedule for the next version of SAM, and then go through the new features in version 2013-920, and then talk about the plans for the next version. So beginning with this version, we're moving from 2 versions per year to 1. And based on the schedule, the release schedule for this year, which we had a beta test period that lasted a few months from July to September, where we had various beta releases that were available for you to download and run and then give us feedback on, and then we made changes based on that feedback, and then we released the version on September 20th. We will be releasing updates as needed, and those updates you can download from the help menu. So on the help menu in SAM, you can check for updates and download them as they're available. And then we're planning to release the 2014 version of SAM in the fall. So the release schedule will probably be similar to the release schedule for this version, but next year. One logistical thing I should mention about our webinar today is I've got all the lines, audio lines muted to avoid noise on the phone lines. If you have a question, please use the chat window to type your question. And what we're going to do is download the list of questions and then post the questions and answers on the learning page. So we'll create a page on the SAM website for the webinar, and then we'll post the Q&A there. If there aren't too many questions, I'll be monitoring them. I may answer a few of them as we go here. But after the webinar, look on the learning page here for a link to today's webinar, and there you'll find the Q&A list on that page. And we'll get that up by tomorrow at the latest. So I showed you where to find information about the current and past versions of SAM. If we look at the SAM user interface on the help menu, there's a release notes item there, and that opens a PDF file with a list of all the features in the current and past versions. So you can use this to see what we've been up to. Okay, folks are still signing in here, so I'll get to the interesting part of the show here briefly. One thing to mention is that the current version of SAM no longer works in Windows XP. And that's because Microsoft is planning to stop supporting Windows XP as of April 8th, 2014. So if you're still using Windows XP, you can use an older version of SAM. You could use SAM 2013-115, which is still available for download. But the current and future versions of SAM will not run on Windows XP. All right, let's get to the new features in SAM. Starting with the financial models, we did a fair amount of work to the utility rates modeling. So this is this applies to residential and commercial financial models, where you provide SAM with information about a retail rate structure and also about an electric load. And then SAM assumes that the renewable energy system displaces purchases from a utility. So there are a couple of changes. Let me find SAM here. And I'll create a PV, residential PV case here to show what's new with utility rates. So the utility rate page is down here toward the bottom. And if you've worked with the utility rate page in older versions of SAM, you'll notice a few changes. We've moved a few inputs around. And we've generalized the inputs so that it's actually more flexible, so it allows us to model a wider range of different utility rate structures. And then we've also changed the net metering inputs, because SAM is now doing monthly net metering accounting instead of the hourly net metering accounting that was doing before. So in previous versions of SAM, net metering, the way net metering was handled, it basically just assumed that all of the power generated by the system was sold to the grid, which is doesn't reflect how net metering agreements tend to work. Now SAM does monthly net metering and rolls over credits to the next month, which I'll show you in a moment. So this new layout on the utility rate page we did this to match the new format for the OpenEI utility rate database. So SAM can download utility rates for a number of utilities, thousands of utilities in the United States, from the OpenEI utility rate database. So this is where the database is housed, and you can read about it here and also get some data about the utility rate databases. The OpenEI group here changed the format for the utility rate database, and so we had to update the input page on the utility rate page in SAM accordingly. We've also made a little change in the download process for when you want to download a utility rate from that database. So let's see. This project, the weather file is for Phoenix, Arizona. So one of the utilities that serves Phoenix is called Salt River Project. And when I click on that utility here, you'll see that only the residential rate structures are displayed here. So I can change this to display either all of the schedules that are available for this utility, just the residential ones, or just the commercial ones. So that's a big improvement. It used to be that you got this big overwhelming list of rate structures, some of which didn't apply to your project. Now you can filter them. So since we're looking at a residential project here, I'm only showing the residential rates. And then I can choose one of them. This is as before in older versions. And then download and apply utility rates. And then SAM automatically applies the rate structure. And as always, you have to check the data on this page to make sure that the data is correct. So it's a good idea to have a copy of the rate sheet from the utility in hand so that you can double check the values here and make sure that the checkboxes are appropriately checked and cleared. And then run simulations and look at your results. Now, as for net metering, the net metering inputs here look similar to the older versions that we've just rearranged them a little bit. So I'm going to do a simple net metering example here to show you how net metering is working now. So let's say we've got a flat rate of 9 cents per kilowatt hour, for example. And we're going to enable net metering. So that disables the sell rate because we're not selling power, we're displacing, we're just getting credits for the power that we avoid buying, basically. And then we have a year-end sell rate. So at the end of the year, any net metering credits that remain are sold at this rate. So it may be the same as the buy rates, it may be 0, or often it's at the utility's avoided cost, which is typically some small number. I'll say it's 3 cents per kilowatt hour. And then you may have a monthly charge. We can put that here. And then you can model time of use and tiered rates, demand charges, and so on with net metering. But I'm just going to do a simple net metering case here. So we've got a flat buy rate of 9 cents per kilowatt hour, a year-end sell rate of 3 cents per kilowatt hour, and a $10 a month fixed charge. So I run simulations. And I can see in the metrics table here, we've renamed these results to make a little bit more sense. So we've got the electricity cost without the system. So this is what it would cost to meet the electric load without the renewable energy system. So that's just your annual electric bill. And then this is the cost with the system. So and the net savings. So the renewable energy system reduced our annual electric bill by about $610 in this case. We can look at the monthly how the monthly net metering works here. So I'm on the graphs tab of the results page, and I'm going to display a monthly graph here. So let me add a new graph. And I want to look at monthly values. And what I want to do is plot the monthly energy generated by the system and the load. So this is the building load. And then the net metering credits per month. And then I'm going to change some labels here. These are kilowatt hours now. And I want to show the legend. And then accept. And then here's my graph. So what I can see here is that the system's energy production on a monthly basis is always lower than the load. So this system produces less energy than the load. And so we get no net metering credits. There's no light blue here. It's 0. I can click show graph data here to see the actual values. So show graph data is up here at the top above the graph. Here's the numbers that are shown in the graph, and I can see that net metering is 0 for all months. Okay, that's because the load is always greater than the system's output by month. So if I reduce the load a little bit, so I can go down to the electric load page and scale it down, I'll scale it by 7.75%. So this is going to scale down my entire load profile by 25% and run simulations there. Now my monthly graph shows that the load is greater than the system energy production for all months except February and then May, or February, March, and April. The system production is greater than the load. Sorry, March, April, and May, right? So in March we produce more energy than we needed. So we get a little net metering credit. We get a credit here. And then in April, we get a credit. And in May, we get a credit. There's no end of year reconciling here because we used up our credits by the time we got to December. So if I make the load even smaller, so let's make it 50% of the original load. Now we see that we get a net metering credit every month, and then there's we get some of the November credit rolled over into December, and then we get a payment for that amount. So you can explore these results and check out help for more descriptions of what's going on. As usual, the retail model, the retail rates model here is pretty involved and takes some getting used to. So I recommend experimenting with it and reading and help. We did create a new sample file to help you figure out what's going on. So if you go to the File menu and then look under Open Sample File and go to Residential Net Metering and Tiered TOU Examples. So I'm going to open that sample file. So this sample file has 3 cases: basic net metering with excess generation, and then a tiered time of use with demand charges case. So the rate structure for each of these cases is different. And then what you'll see is that on each input page, we wrote up some notes that describes what's going on. So if you just start at the top, at the location or resource page, and read through the notes, look at the inputs, you'll learn a lot about how to use SAM to set up a PV system, and also how to model these different kinds of rate structures. So again, that's a sample file that you can find from the File menu, Open Sample File, and it's the Residential Net Metering and Tiered TOU examples. A couple questions coming up here. Can we have a copy of the presentation? Yes. I'll put a copy of the presentation on the SAM website along with a recording of this session, so you'll be able to watch a video of what I'm going through here. Can the yearly net metering credit be tied to another date instead of 12/31? No. SAM assumes that the monthly accounting happens on the last day of each month. So if we look at the basic net metering case here, so run simulations, go to the time series tab. I'm going to look at the hourly results here. And let's look at the net sales purchases with system. So this is the dollars that are being paid or received by the project on an hourly basis. And what you can see is that these are negative numbers. So it means that this is your bill, electric bill, and that it happens on the last day of each month. And that reconciling happens on December 31st. So you can't adjust that date, unfortunately. We're trying to strike a balance between making the model flexible enough to be realistic, to be able to model projects in a realistic way, and keeping it from being too complicated to use. So the simplifying assumption that we've made in this case is that you pay your monthly bill at the end of each month, and that annual reconciling happens on December 31st. Thanks for those questions. An important consideration when you're modeling these kind of projects is the load, of course. And typically the only information you have is a customer's monthly electric bill, and SAM needs hourly information about the hourly load to run, because it's an hourly simulation model. It turns out that there's a database of synthetic load data that's available, again, from that OpenEI website that I showed you for the utility rate database. And we've written another sample file, or prepared another sample file for you. So if we go File, Open Sample File, and go to this one that says Samuel Download Building Load Data. What this does is, this is a script. This is a Samuel script, which you may or may not be familiar with. Samuel is a scripting language within the SAM user interface that allows you to set the values of inputs and run simulations and then read values of results. So it's a way to automate simulations. And this sample script makes it possible for you to download a load data file from the OpenEI database and then put it on into the electric load page. So once you open the sample file, go to the Samuel script tab here, and then just click Run Script. And then you'll be given a series of prompts. What I want to do here is download a residential load file. So I'll enter 0 for residential. And then it gives me the type of residential building, and you'll have to go to the OpenEI website. The link is in the comments in the script here to get a description of what these different low, base, and high building cases are. But for now, I'll just put in 2 for a low building case. And then the script does a little thinking. It's going to the website and downloading the data, putting the data onto the utility rate, the electric load page in the case of the file. When it's finished, it displays this message. And then click OK and go over to your case. And if you go to the load page, you'll see that the load data was downloaded successfully. These load data files were developed using a computer algorithm, and they're based on the TMY3 weather data. So you'll need for this load data to be most useful, what you'll want to do is find the TMY3 file for the location closest to your project site. In this case, we're using this Phoenix Sky Harbor TMY3 file, and then go to the and then run the script, and then you'll have a weather file and load data that are matched. Of course, that load data doesn't represent any specific building or house. It's synthesized data, but it's at least a way for you to get started doing some analysis for a renewable energy system that displaces a residential or commercial building's electric load. Question here, does SAM have PPA analysis tool with calculations based on peak and off-peak rates? Yes, but that's a topic for another day. The PPA models, so if we create a new file here, and let's stick with PV, these utility IPP models, independent power producer, and then these advanced ones, these are all PPA models. And the PPA models have a time of delivery schedule option, so you can have a price that comes with a set of adjustment factors that vary with time of delivery. Can we alter the total kilowatt hours in the sample data? Yes. So let's go back to this script. So we have electric load data here. This is the data that was downloaded from the OpenEI database. And we can use this scaling factor to scale it up and down to whatever total kilowatt hour value we want. So, if you're looking for a total kilowatt hour value that's half that much, then just put in the scaling factor of 0.5, and that scales it down. So look at this total number. Okay, and we're gonna do a whole webinar on modeling these types of systems, where we'll go into detail about how to work with the load data, and you should also check the past webinars. We've got some of that material covered for past versions of SAM. So there are some resources where you can find out more about how to do that, how to work with the electric load page. All right, let me switch back to my PowerPoint presentation and see how we're doing here. I think we've covered all of that. All right, so next is new features for the PV model. The biggest thing we did for this version is to add some new options for the inverter model. So let me show you those. Head back over to SAM, and I'll create a new PV case. Let me do a utility scale, one of those PPA model systems this time. So on the inverter page is where you'll see the new inverter options. If you're familiar with older versions, one thing you'll notice is that we've changed the way you choose a model here. Hopefully this makes it a little clearer. You can see what the current model is. It's the inverter CEC database option. We're on the inverter page. And if you want to change that, you can click the change button. And this is a list of the available options with a little description. So in previous versions of SAM, we only had the inverter CEC database option. So that's the option where you choose an inverter for a list from a list here. And you can type a few letters of the inverter name. So if you want to see what the SMA inverters are, you just type SMA and there they all are. So maybe there's an inverter that you'd want to model a system with an inverter that is not in this list. If that's the case, then you can choose the inverter datasheet option. Click OK. And now, instead of having a list to choose from, you have a table of specifications. And these are all specifications that you would typically find on a manufacturer's data sheet. So you just get your manufacturer's data sheet and copy the values from there into here. And we've tried to use names for these variables that are general enough that you can figure out, every manufacturer uses a slightly different name, but you should be able to tell what we're talking about here. And then you can look in help, of course, for hopefully help. So here's a description of what all the variables mean. And then we have another option for the inverter, which is the inverter part load curve option. So this is, again, uses data from a manufacturer's data sheet. But instead of using or it also allows you to put in a table of efficiency values. So in some cases, you may have, this efficiency table that shows what the inverter's conversion efficiency is at different power levels. So from 0 to 101 in this case. Okay, so 2 new inverter model options. And that's to address, we get lots of questions from folks who'd like to model a system with an inverter that's not in the CEC database. So now you have a way to do that. That's been available for the module model for a few versions now. The CEC performance model with user-entered specifications. If you want to model a module that's not in the CEC or Sandia libraries, then you can enter data from the manufacturer's spec sheet here. Okay, I'm just going to go back to the default options here to, in case I want to run simulations to show you some of the other new features. Can we use this for off-grid system? No, SAM is for grid-connected systems. It does not have an option for off-grid systems. There are some other models available for modeling off-grid systems, like Homer is probably the most well-known one. RET Screen is another one that does some off-grid modeling as well. The other improvement we've made to the PV model is on the array page, we've had this option to let SAM help you choose the number of modules per string and number of strings in parallel and inverters. So you specify a DC capacity, and then SAM tries to figure out how many modules and inverters to include in your system. That's been available for a while, but what we did in this version is added this DC to AC ratio. This is something that system designers are used to working with. So typically you want to oversize, and I say oversize in quotes, your array compared to the inverter, because you're rarely going to operate the inverter at its full capacity. So by having a slightly larger array, you're going to make better use of your inverter, and so you typically do that using this DC to AC sizing ratio. So hopefully this will be an improvement to some of you folks who are using this option. And then you get some feedback here in the sizing messages. So if I put in, let's say I put in a DC to AC ratio of 1.2, it may, depending on the choice that you've made for the module and inverter, you may not, SAM may not be able to find the number of modules and inverters that results in the DC to AC ratio that you want, and that's the same as for the desired array size. So these inputs here are desired values. So you're trying to design a 20 megawatt system in this case. We've got 19.998, which is pretty close to 20 megawatts. And then the DC to AC ratio, in this case we're using a really small inverter, a 3.5 kilowatt inverter for this 20 megawatt system. So we're able to achieve our DC to AC ratio, but that's not always the case. If we use a solar on, let's see, something more, let's see. What I'm going to do here is go back to the default inputs here. So on the case menu, I'm going to click case, reset inputs with default values, because I have a module and inverter that are not appropriate for this 20 megawatt system, and that's screwing up my demonstration here. Okay, so now we have a 333 kilowatt inverter and a 300 watt module. We're trying to design a 20 kilowatt system. I said I want a 1.1 DC to AC ratio, and based on the module and inverter that I chose, the actual DC to AC ratio is 1.09, and that's because of the voltage and power capacity nameplate ratings of the module and inverter are such that I can't get exactly 1.1. Anyway, you can read about what SAM is doing behind the scenes here in HELP. There's a detailed description of the algorithm in sizing the flat plate system in HELP. So here's the algorithm. Here's the steps that SAM goes through to do the sizing. So you can see, if you follow these steps, you'll see why SAM can't always find exactly the capacity and DC to AC ratio that you're looking for. In any case, we only recommend using the specified desired array size option for preliminary sizing. When you're modeling a system, you're going to want to use the specify modules and inverters option and put in numbers yourself, and then you can fine-tune your design. So you can start by doing specify desired array size, and then see what SAM comes up with, and then put those numbers in here and specify the values yourself, and then refine them. Anyway, that's more detail than I meant to go into on this. The main point here is that in the new version of SAM, we have a new input here, the DC to AC ratio, to help you with sizing. The other thing we did is on the PV subarrays page, has to do with shading. So we fixed a few problems and we added some new features. So let me start with shading mode for one-axis tracking. So this only applies to arrays with one-axis tracking. So that's common in large arrays where you have long rows of arrays that are lined up next to each other, and they're tracking in one direction to follow the sun's motion across the sky during the day. They're typically horizontally mounted, and then they turn to follow the motion of the sun. And depending on if the rows are very far apart, then the neighboring modules in neighboring rows are not going to shade each other. And in previous versions of SAM, SAM has assumed that the system is designed with no self-shading for one-axis tracking. So that means that the rows are too far apart for them to shade each other. Of course, in an actual system, you don't want you're spacing the rows that far apart. Increases your land cost. So you want to do some kind of an optimization where you get the rows as close as you can to each other without causing too much shading loss. So now with SAM you can model that situation because the one-axis tracking, an array with one-axis tracking, is now accounting for shading of rows, shading of modules in neighboring rows. So that's this self-shaded option here. The none option, this is what SAM used to do. So it modeled one-axis tracking with no self-shading, which is an unrealistic way to model most systems. So we've included the option here just so we have a way to compare results from the new version with older versions. But in most cases, you'll want to use this self-shaded option. And then the backtracking option, so that's a technique where in the early morning hours and the late evening hours, the tracking system rotates the modules back away from the sun in order to minimize shading by neighboring rows. So the backtracking algorithm had a couple of problems that we fixed. But the main thing now is that the backtracking algorithm, when you compare it to the self-shaded option, you'll be able to see the benefit of backtracking, which was not possible in previous versions of SAM. In previous versions of SAM, you could see what the annual output was with backtracking, but it wasn't possible to see what the benefit was. And then we removed, we had a row width and row spacing inputs to define the distance between the rows. We've switched to the more conventional ground coverage ratio, which gives you a little bit more flexibility when modeling shading in SAM. Can SAM model solar systems with modules that include optimizers? Not really. I think you're talking about DC to DC converters and those sorts of things. And SAM doesn't have component models for those that kind of equipment. Any issues with 1,000-volt DC systems? Not that I'm aware of. I think we'll take that one offline and answer it on the webinar website. Do we have an app for iOS or Android for this software? Nope. Sorry. You got to run this on a computer because you need a big screen to see all of these inputs. So it's a desktop application at the moment. All right. Oops, that's not what I want. Okay. And I think that's good for PV. The next thing I wanted to show you is we've got a new solar water heating model, and I'll just take a quick moment here to show you that. So File, New, Solar water heating model. So the solar water heating model is for a residential or commercial rooftop system. And we've completely reworked the internal calculations for the solar water heating model, which means that it's much faster. If you use the older version, you'll remember it takes 30 seconds or something to run. This one runs in a blink of an eye. A lot of the inputs are the same as the older version, but we've tried to come up with more intuitive inputs. Some of the inputs in the older model were kind of esoteric. So an improved water heating model, it still uses the SRCC collector library, where you can define your own. It's got some new features that the older version didn't. For example, you can import hourly data for the hot water drop profile. So this is the hot water demand, and then you can also input hourly data for the mains temperature. There's an internal algorithm that calculates the mains temperature based on the ambient temperature. But if you've got your own mains temperature, you can import that now. That wasn't possible before. And you can also import a set of hot water set temperatures. So a couple of improvements and mostly just a performance enhancement for the solar water heating model. Can SAM model solar systems with modules that include I already answered that one. Can SAM interface with SunEye? The answer is yes. You can check the help system for instructions, but you can. SAM will work. The PV model will work with shading data from a couple of different shading analysis tools that are available on the market. Okay. We made some improvements to the wind model, so I'd like to show you those. Again, just a quick demo, so you know of the new changes. Create a new file, and that's not what I want to do. I want to do File, New, and go down to Wind Power, and let's model a big wind farm here. So the first thing I can mention is regarding wind data files is if any of you work with the Windographer software, it's wind resource data analysis software from Mistaya Engineering. There's an export in Windographer. There's an option now to export data from Windographer to the SRW wind format, which is SAM's wind data file format. So you can use Windographer wind data in SAM now. The new siting considerations page. This is an informational page, so it doesn't affect simulations at all. But it interfaces with the NREL Wind Prospector website, and it basically lists siting considerations for any location in the United States. So if you click Download Siting Considerations, in the default case, you'll get a message that says no latitude and longitude found for this site, and that's because these sample wind data files that come with SAM don't have latitude and longitude information. These are sort of general sample files to help for you to get started with analysis. The siting considerations page needs latitude and longitude information. So we have an option here where you can, instead of reading the long data from the weather file, you can just type it in by hand. So I'll use that option, and I'm going to do it for Hood River, Oregon, which is down the road from me here in a windy place. And here we can see all of the siting considerations for Hood River, Oregon. So there's land, who owns land within a 10-mile radius of the location that I typed in, what agencies, federal, local, state agencies either own land or manage land in the area, and then what potential regulatory regulations might affect developing a wind farm in the area. Again, this is just informational. It doesn't affect, typically there would be a cost associated with dealing with each of these issues. That these are not linked to the cost page, but it does give you a sense of what you might have to deal with to build a project at that location. On the wind farm page, a couple of new things for the wind model. One is that we've got new options for the wake model, so you can choose from 3 different wake models, and you can read about those in help. So the wake model is modeling the effect of the neighboring turbines on each other. So if the wind is coming from the south, for example, it'll hit the turbines in the front row, and then those turbines will cause some turbulence and slowing of the wind when they reach the turbines in the second row, and so on. So the wake model models those effects. So a couple of new wake models, and then we've got a cool import turbine layout file option. So you can either specify the turbine layout using these inputs here, or you can just set up a CSV file, and there's a sample wind farm layout file that comes with SAM. So I'll use that one. It's in CSAM 2013-920 samples, and it's called sample turbine layout. So if you open that, hey, who keeps putting smiley faces in my presentation? Anyway, that's not a realistic wind farm layout, but obviously you can set up your own, and it's just two columns of data. You can look at the sample file to see how it's set up. Is SAM useful for vertical axis wind turbines? I don't think we have any vertical axis wind turbines in the current library. But any turbine that can be characterized with a power curve, you can model in SAM. So I suppose you could model a vertical axis wind turbine in SAM. Siting considerations would also be useful for large ground mount PV projects. Yes, that's true. And now that we've figured out how to implement it for the wind model, it'll make it easier for us to do it for the other technologies as well, provided we have access to similar data sets. Do we have any plans for future development of the wind module in SAM? We do. We do have resources for maintaining and updating the wind model. We don't have any specific plans at the moment, but we always welcome your suggestions. So if you've got any special requests, please send them our way, and we'll take them in consideration. And then I'm not going to go into these in any detail at all. As usual, bugs come up, so each version we take care of those bugs. And so there's a list of issues that we found with the concentrating solar power models. Startup energy calculations that affected all of the models were addressed, and a few other fixes, and those are described in a fair amount of detail in the release notes, which I can show you again where to find those. Release notes. So here under CSP, here's a description of all the bug fixes, and some of these fixes have a significant impact on the results. So I know that a number of folks are using legacy versions of SAM for CSP for contractual reasons or other reasons, and so that's fine. But just be aware that we have been making a lot of improvements to the CSP models in each version. So the current version is always what we consider to be the best and most accurate model. And we also try to quantify the impact of each of the changes on the results in SAM, so that information is in the release notes. Could we analyze desalination plants integrated with solar thermal plants? The answer is yes. People have done it and are doing it. In fact, we've got some folks looking at that specific question as we speak. But SAM is primarily designed as a power generation model. So the solar field in SAM is hooked to a power block, and the power block determines how the solar field is sized. So there are some limitations to trying to model a desal plant in SAM, but it is possible. There are some workarounds that you can use to model to do that. And we've been looking at the possibility of putting in a desal model, integrating a desal model into SAM. So that's something that we may see down the road. There's some challenges with that we need to deal with. But again, if that's a feature that you'd like to see, let us know, and let us know specifically what kinds of ways you would use such a model to help us figure out whether and how to implement it. Let's see. Can you see how much the wake effects percent are on the output page? Okay, so I have this silly smiley face wind farm here. So let me reset to defaults here so we get something reasonable, and then run simulations. And can we see the effect of wakes in the results? So we don't. The way you would investigate the effect of wake effect on your outputs would be to run, probably set up a couple of cases, and then so we could set up a duplicate case and use. So we've got this layout here with 750 meter row spacing. If we make them closer together, let's be crazy and say 500. Okay, that brings them closer together. I'm not sure what the prevailing wind direction is for this particular case. But let's see, we zoomed into, whoop, I'm going to switch over to the other case. And we're zoomed into June 27th to July 7th. Okay, so now by switching between the cases, I can see the difference in the annual output. I'm doing kind of a qualitative comparison here. It doesn't look like moving those rows together had a big effect. So that's one way to do it, is just to set up two different cases and adjust the row spacing between the cases. And I think we probably want to look at the turbine spacing here, because I think the prevailing wind may be from the west. So we'd have to look at our wind resource data to see where the prevailing wind is, to see a bigger effect of spacing. And then the other approach would be to use a parametric analysis. So you click this funny button down here that says Configure Simulations, and then add parametric simulation. And I'm not going to go through the steps here, but hopefully this will whet your appetite. You can look in help for instructions on how to set up a parametric analysis. Anyway, you could do a parametric study on the turbine and row spacing to see how it impacts the hourly output. Okay, let's see. There are a couple more things I wanted to mention before we close. So a few other general enhancements and fixes. The energy loss diagram has some enhancements. Where's Sam? Let me go to a PV case. This will take just a second. and then run. And look at the loss diagram here. This looks a little cleaner and has a little bit more information than it did in older versions. By the way, this dancing message here is telling me that I need to click the button and see what's going on here. It looks like this is we're back to PV model here. It says the inverter is undersized. The array output exceeded the inverter rating for 4 hours. There are 8,760 hours in a year. It's telling me that the array output was more than the inverter capacity for just 4 of those 8,760 hours. So I'm going to ignore that message, just in case you were wondering what was going on with that dancing sign up there. Okay, so this loss diagram is improvement over previous versions. And in the minute or two that we have left here, I'll flip through all these apps. We changed the labels for some of the hourly outputs. We discovered some issues with the net metering outputs. So we're going to fix that in an update. And then there was a problem with file paths in the Mac version of SAM. That's fixed. There's some new advanced inputs for the PV watts model that give you some more flexibility in how determining how PV watts does temperature correction for the cell temperature calculation, and then some fixes to the geothermal model. And then to close out here, just take a minute to talk about what we're doing for this coming year. We're working on a 3D shading model for PV. That's something a lot of you have requested. So you'll be able to draw a three-dimensional picture of your site and put the PV panels on it, and then Sam will figure out what the shading is going to look like. That's going to be pretty cool. We're going to enhance the PV module model so that it will work with the new IEC 61853 test data for you PV geeks out there. And then we're going to do for the statistics geeks out there, we're going to improve the exceedance probability capability in SAM to make it a little bit more flexible. Right now it has some limitations that are pretty limiting. So that's going to be coming up in the next version. We're going to try to make some radical changes to the user interface, I hear. So we'll see how that goes. Hopefully things will be easier to use in the next version. We're working on some validation work. This is something that a lot of you have asked about. So we've gotten data from fielded operating systems, and then we've modeled those systems in SAM and compared the results and written up those comparisons. So keep an eye out for those on the publications page on the SAM website or on the NREL publications page. We'll let you know when that work is published. We're gonna work on the weather data format. Right now, SAM only works with a few specific file formats that are developed by others. We're going to develop a SAM-specific weather file format that's more flexible and easier to work with than the current formats. And we're busily writing away new reference manuals for PV. That's been a long time coming, and also for wind and I think for the solar water heating models. So better documentation of the algorithms behind the scenes. So that's what's coming in 2014. And as usual, please let us know. You can email us, use the contact sheet on the SAM website, or post something on the forum. If you've got something you'd like SAM to do that it doesn't, let us know, and we'll see if we can make it happen. Or just get in touch if you've got questions about SAM or anything you'd like to ask. And that's it for the new features in this latest version of SAM. I'll stay online for a minute or two in case someone's got a last-minute question they'd like to ask. But otherwise, thanks a lot for participating. And check the learning page on the SAM website for the next webinars coming up. And do stay in touch.